Hi folks. Over the last couple of days we've looked at graphing quadratic functions from various forms. Today we're going to look at finding the equation if we're given the graph. So for now we need to know either the vertex or the x-intercept. If we know the vertex, we're probably going to think about vertex form, which is a x minus h all squared plus k. And again, the letters are arbitrary. It doesn't matter what letters we use, just their position and the form. For the x-intercepts, it was something like this: x minus p and x minus q, where we've got x-intercepts of p and q. And a is some sort of steepness and direction of opening coefficient. So in order to determine what a is, we need to know one other point. So here are the steps if we want to find the equation of a graph, if we're given the graph. Sub known values into either factored or vertex form, and a will start off being unknown. Then we'll sub another point in to find a, and then write in whatever form is requested. So let's take a look at a couple of examples here. It says, write in any form. Well, that's kind of helpful. Now let's think about what we know in this first one. We know the x-intercepts. They're at -3 and 1. We also know this other point over here, and it has coordinates. It just shows -6, but it's the point 0, -6. So think about that. We know the x-intercepts. What form are we going to start from? Should it be vertex form or factored form, where we know the x-intercepts? I think it should be factored form. Okay. I know that this equation takes the form a. Now there's an x-intercept at -3, so there's going to be a bracket that says x plus 3. And there's an x-intercept at 1, so there'll be a bracket that says x minus 1. That's the general form of this equation. The question that lingers is, what is the a value? And to find that, we're going to sub in the point 0, -6. Because the big gag of algebra is if you get down to just one unknown, often you can find that unknown. So if I'm going to sub in the point 0, -6, let's be real clear here. 0 is an x value, -6 is a y value. Looking at this equation, I'll put in -6 for y, and I'll put in 0 for x. Let's see if we can sort things out here. So that gives us -6 equals -3a. Or if I divide both sides by -3, I'll just minimize this thingy. That will give me a equals 2. Does that make sense that we have a positive a value for this? Yeah, it does. All right, so we were at this version of the equation over here. The only problem is that we didn't know what a was, and now we do know what a is. So now I can write the equation of that function as 2x plus 3, x minus 1. I'm going to go to the graphing calculator and make sure that I'm correct. There's the equation that I think it is. Let's see if it has all the right properties. It has an x-intercept here at -3. It has an x-intercept over here at 1. And it has a y-intercept at -6. I can read that off the points that are appearing x and y1 equals, just below the graph. Okay, so we found an equation for that parabola. Now it says here that we can write it in any form. If instead it told you that you had to, say, put it in trinomial form or either in vertex form, all you would do is start to convert. So if it had to be in trinomial form, you'd FOIL out your brackets, and then you'd multiply out. If you needed to put it in vertex form, you'd take this and use your -b over 2a and find out where the vertex is. But here it does say any form. And even if it specified the form, you would start by finding some form that was helpful and then converting it into whatever the requested form is. Let's check out another one. So in this next one, it's a little sneakier. We know a point, 2, 2. Okay, there's our point that's given to us. We also know this point right here. This is the point 0, 1. And it is an x-intercept. There's other stuff we can reason out here. I mean, if this is the axis of symmetry at x equals 3, then the vertex is at 3 something, which might make us think we should use vertex form. But I don't know the y-coordinate of the vertex. Let's see what else we can reason out, if anything. We can use the symmetry of the graph to reason out that this point right here is 2 to the right of the axis of symmetry, that there is another x-intercept at 0, 5, because a graph or a parabola is going to be symmetrical about its axis of symmetry. So it looks like we know here that the x-intercepts are at 1, I won't write that as a point, that they're at 1 and 5. We should probably use factored form in that case. So maybe I'll start up here. You have an extra page to write this on, but I don't. So I'm going to say this takes the form y equals a. Since there's x-intercepts at 1 and 5, x minus 1, x minus 5. Now we need to figure out what a is, and to do that we sub the known point. Sub 2, 2. And again, just to be clear, this first 2 is an x value, the second 2 is a y value. So if I throw that in, what will I get? 2 equals a by 2 for x in both spots. And this just helps us suss out how steep it is. So that will give me 1 times negative 3. Okay, so negative 3a equals 2, or a equals negative 2/3. That's fine. It does make sense that it should be a negative value because it's a parabola that opens downward. Let's put this all together as a single equation then. So in the end, we should get y equals a is negative 2/3, x minus 1, x minus 5. If we write it in factored form. And again, you can change forms afterwards if you want. Let's check on the graphing calculator whether this works out. There's the equation. Let's graph it. Let's see, it does have an x-intercept at 1. It's got a vertex at 3 as expected. Does it contain the point 2, 2? Yep, it appears to. And then it's got an x-intercept over here at 5. So it has all the features we were expecting. Let's do 2 more. So I'm going to mark these up and just write the things that I know on them. Like on this one in C, I know that there's a vertex at negative 2, 0. Now once I know that, I mean, should I use the vertex form or the factored form? Remember, vertex form lets you use the vertex. Factored form tells you about x-intercepts. Here we know where the vertex is, so I actually know the form of the equation. It's going to be y equals, for now, a, or the steepness coefficient, is unknown. Something squared. Okay, let's see, x. If the vertex is at minus 2, then I have an x plus 2 here, and it's been lifted up 0 units. So that tells me that this would be a parabola with a vertex at negative 2, 0. Okay, that's a good basic equation. Now we got to follow Anna's advice and do the next right thing. The next right thing is going to be to sub in a point. We know this point. Negative 1 is an x value. 3 is a y value. So let's see what happens. It'll get us down to just one variable, which is good. So 3 is the y value. Negative 1's going in as the x value. Oh, this is so exciting. So that's 1 squared, where a is 3. So now we can write the final equation. This should be 3 x plus 2 all squared plus 0, or just y equals 3 x plus 2 all squared. You can go to your GDC and make sure that it is indeed a parabola with a vertex at negative 2, 0 that passes through negative 1, 3. And the question said write it in any form. Great. There's an any form. If instead you wanted to put it in trinomial form, you could you could just work out that bracket. You FOIL it out, so you get x squared plus 4x plus 4. So we'll get 3x squared. Sorry, a little pen issue here. Plus 12x plus 12. If you wanted to factor this, you'd actually end up back in vertex form, because vertex form in this case really is the same as a factored form because there's no lift up or down. It's got a vertex on the x-axis, so it is telling you the x-intercept. But again, this is just saying write it in any form. I think we've got a lovely form right over here. And I would think of that as a vertex form rather than factored, though really it is both in this case. All right, last one. Let's catalog what we know. We know that there's a vertex at 2, -3. We know a point at 0, 1. Not a particularly special point. It is the y-intercept, but it's just some other point on the graph. Since I know the vertex, I'm going to use, wait for it, vertex form. So if the vertex is at 2, -3, it'll take the form something, bracket x minus 2 all squared minus 3. Now we're going to sub in the point that we know, which happens to be 0, 1. Again, 0 is an x value, 1 is a y value. Let's see what happens. So 1 equals a, 0 minus 2 all squared minus 3. Let's move some stuff around. So that'll be 4 equals a by -2 squared, or 4a equals 4, or a equals 1. Oh, I'm not going to put a square around that because that's not my final answer. Lastly, I want to write the actual equation of this. So it's going to be 1x minus 2 all squared minus 3, right? Because we found out the value of this a up here. Now some of you might look at that and think, I don't really like seeing 1 as a coefficient of anything. So you might want to show it like this. It does make sense, though, that it is a positive a value, and that's because the graph is opening upward. So that should be our final answer. You can do some practice on these on page 39 to 40. You don't have to do every single one, but you might want to do a smattering. Numbers 1 and 2, I think, are mostly from factored form. Number 3 is from written descriptions, and number 4 is from vertex form. So let's say a smattering. Maybe spend 20 minutes here. Remember that you can find the full work solutions on Google Classroom if you want to see the process, and also let me know if you have questions. Good luck, folks.